All right, this is a video on finding linear functions of best fit, and I'll start off with an introduction, some steps to follow, and then we'll do an example both by hand and on Desmos. Okay, so I have a whole list of steps to follow. Probably good to have in your notes, write these guys down. But let's go through them. First, you definitely have to plot your points. Okay, so I'm assuming you have some x and y data. You're going to plot your points. And then I don't want you to just assume that you're going to find a linear function of best fit. Actually look at the data. Does it look like a linear pattern? Okay, and if it's not, then choose a different function to consider. You're going to draw a line through your points. Okay, it doesn't have to connect any particular points. It doesn't have to go through any exact points. You want to roughly split your points in two. You want to certainly follow the trend of the data, and you don't want to let a single outlier point determine your line. So maybe you have one bad piece of data and you don't want to let that particular, maybe uncertain piece of data determine a lot of the characteristics of your line. Once you have your line drawn, you'll determine the equation, and then put your brain on it. Put your brain on that equation. Think about your slope and your y-intercept. Do those numbers actually make sense? Do those coefficients in your equation kind of make sense? Okay, so we're going to do that first down here, and then I'll go through the Desmos steps, and we'll do that over on Desmos as well. So we have some real-world data on quantifies income inequality by tracking the share of income earned by the middle 20% of all families. Okay, so if you divide all families into sort of percentiles based on their income, let's find the middle 20%. So from 40% to 60%, that middle 20. Now, obviously, if everyone earned the same amount of money, the middle 20% would earn 20% of the overall income. But in reality, the higher earners earn a higher share of the total. I think it's interesting to look at some trends over time to get a sense of how maybe those numbers are changing, and it gives you a sense of maybe how income inequality might be changing over time. So what I have here are for the years 1950 to 2018, the percent of income earned by the middle 20% of families in the US. So our job is to plot the data and find a line of best fit, and then use our equation to make some predictions. I think in the interest of time, we're only going to use the Desmos equation to make these predictions. We don't need to go through that process twice, but we can make a prediction to 2030. Will it drop to 10%? What will it be in 2400? Is that realistic? I wonder if it might be negative, and therefore it wouldn't be realistic. And then we'll also redo it on Desmos, as I was saying. So let's plot the data first, and that's often the most maybe tedious part of it. I'm going to graph years since 1950, which means the 1950 would plot up as 0, and then we would have a 10, 20, 30, 40, 50, 60, and 70. Okay. And then let's plot percent over on the y-axis, and I need to think carefully about my scale. Going from, let's have this be 15, go up by 0.2, say 1, 2, 3, 4, 16, 1, 2, 3, 4, 17, 1, 2, 3, 4, 18 up here. Hopefully that captures that pretty well. 1950, we're at 17.4, so that's right here. 1960, we're at 17.8, so it looks like it went up a little bit. 1970, we're back at 17.6 for a couple different decades, 17.6, and then another 17.6. And it looks like things really start dropping. In 1990, we had 16.6, so that's year 40. This is 16.246. In 2000, which is year 50, we had 15.4, so that is right there. Another 15.4, and then down to 14.9. What this is telling me is that income inequality is increasing, because the percent of aggregate income that this particular group of families we're thinking about is getting lower. And so probably that means that families in the higher percentiles are earning more and more money over time. So we need to throw in a line here. I'll do it in purple. And I think for my note-taking app, it might be easiest if I just sort of sketch one in and then see if I can think what I can do here. Let's see if this, yep. so I can sort of drag it a little bit. So we want it to roughly split our points. We want it to follow the general trend. I'm going to choose something like that. Okay, so it's not perfect, but I think it's pretty good. And so I'm going to pick a couple clean points. And hey, look at this. We have an 8. It goes to that point almost exactly. So I know my y-intercept right away is 18. Let's pick another point that it goes through pretty cleanly to help with my slope here. I'm going to say it goes through, I think, this point pretty cleanly. Normally you want to pick points that are pretty far apart, but since it goes through those 2 points so cleanly, I'm going to choose those. And so this is year 15, comma, let's see, 17.4. And this is year 0, comma, 18. Okay, so we can find a slope. We know the y-intercept is 18, but we can go do our math right now. So our slope is a difference in the y's, which is 18 minus 17.4, divided by the difference in the x's, which is 0 minus 15. So that's going to be a negative 0.6 divided by a negative 15. And I'll get that on my calculator. I get a slope of, it's a positive 0.6. So I get a slope of negative 0.04. Okay, so what that means is every year the data are dropping by about 0.04%. Okay, so over the course of 10 years you drop by about 0.4%, and over the course of 100 years you drop by about 4%. So those numbers seem to make sense with our numbers with the data. So we have an equation y equals negative 0.04x plus 18. Okay, so that's the equation we got by hand. I want to run through it on Desmos quickly here, reminding you of these steps. Plot up your data, look at the graph, use this form, and then Desmos will basically give you the answers. Okay, it'll also give you the correlation coefficient. So let's go over there. My cursor, my pointer doesn't work on Desmos, so I'll just try to verbalize what we're doing. And I already have my data graphed up and typed in here. So I am going to go ahead and type in the slope-intercept form that we want Desmos to use. So we're going to type in y1, and then we're going to type in this tilde at the bottom of the screen, and then m times x1 plus b. Okay, and so you can see that those ones, the y1 and the x1, we're just throwing those in because those are the names of the columns in our table, x1 and y1. Okay, let's see if we can copy this over to my screen, to my other screen, and get it pasted in here. And we'll do a little bit of comparison. Oops. Let's see if it'll let me expand this here. There we go. Okay. Okay. So just comparing here. Okay. Let me get things kind of clumped up a little bit here. Okay, so we have the equation by hand up top and the coefficients down below. So we got a slope of negative 0.04, and Desmos agrees with us. Okay, so that's pretty nice. And then separately, we got a y-intercept of 18, and Desmos is in pretty close agreement with us as well. All right, we are then asked to make some predictions. What will the share of aggregate income be in 2030? And I'm going to set these problems up for you. I'm not going to fully solve them, okay? So 2030 is, we need to think about the fact that that's year 80, since all our numbers are based on 1950 being our starting point. So we would just type in y equals negative 0.04 times 80 plus 18. And we would use our equation by hand to solve. I think I said earlier we would use the Desmos equation, but I changed my mind. Let's use the equation by hand. When will the share of aggregate income drop to 10%? Well, percent is our y value, so that's 10 equals negative 0.04x plus 18. And we would just solve for x there. Subtract 18 from both sides, divide by negative 0.04. And then when will the share of aggregate income be? What will it be in 2400? So that is in our new time scale, that is year 450 years past the year 1950. So we would just use y equals negative 0.04 times 450 plus 18. And just as a means of bringing closure, that actually we get a y value of 0, okay? Meaning 0%, or the middle 20% of families will be earning 0% of the aggregate income. Hopefully that doesn't happen. Hopefully this graph pattern, or the pattern flattens off, maybe starts increasing again. All right, good place to stop. I think we did it. There we go.